Rather than continue with generalities, in this lecture what I'm going to do is I'm going to talk about just one particular fractal. And it's one that you already know. We're going to look at it a bit more deeply. We're going to look at it numerically and symbolically. We're going to learn how to work with the Cantor set. And specifically, we're going to learn how to do two things. If we're given a number which is in the Cantor set, we're handed it in the ordinary way as a number. We're told, for example, here's the number 1/13. Well, we could associate to it an address. It's a string of letters that tells us exactly where it's located in the Cantor set. And then at the very end, a little bit, we'll talk about going in the opposite direction. If we're actually given this address as a string of letters, how to get back the number in an ordinary sense. So let's begin with that first process. Given a number between 0 and 1, which is in the Cantor set, we're going to figure out how to associate to it something we'll call its address. Now the address will consist of a string of letters, L's and R's, an infinite string. It'll start someplace and then just continue forever, and this will be called the address of the number. Now how do we do that? Well, as you might have guessed, L and R stand for left and right. The Cantor set consists, as we know, of a left piece and a right piece, each of which is a small size, in fact a 1/3 size copy of the whole set. So here I'm showing you the Cantor set up above, and I have a red box around the left piece and another red box around the right piece. Given any number in the Cantor set, we can first ask, in which piece is it located? And our response will be either it's in the left piece or it's in the right piece. In other words, we'll say either L or R. The example that I'm going to work with here is the number 1/4. And this is a number in the Cantor set. In fact, it lies in the left piece. How do I know this? Well, I know that the left piece goes from 0 to 1/3, and 1/4 is between 0 and 1/3. 1/4 is less than 1/3, so the number 1/4 must lie in the left piece. What that tells us is that the address of the number 1/4 begins with the letter L. But the left piece of the Cantor set is a copy of the whole set, and we can now ask, well, where in this piece is 1/4 located? So we want to get a bit more precise, not just to say it's in the left piece, but where is it in the left piece? You see, the left piece itself falls into two pieces. There's a left piece and a right piece, both of which are pieces of the big left piece. Now, it might get confusing if we don't give a longer label. So here what I'm showing you is if I look at the left piece of the Cantor set, that it itself falls into two smaller pieces, the LL piece and the LR piece. Now we're not actually looking at it, but over on the right you can see the right piece of the Cantor set, and it also falls into two pieces, the RL piece and the RR piece. Now where is the number 1/4 located? Well, a clever way to answer this question is to enlarge the piece. That is to say, enlarge the left piece of the Cantor set, making it as big as the original Cantor set. And the way that we do this is very simple. We simply multiply every number in the left piece by 3. So 0 stays where it is, but 1/3 gets pushed out to 1. And the number 1/4 goes along for the ride. It goes somewhere. Where does it go? Well, it goes to 3/4, right? We were multiplying by 3. So if we enlarge the left piece to make it match the entire Cantor set, then 1/4 goes to 3/4, and we are asking, where does this number 3/4 or 3/4 lie in the original set? And the answer is, it's in the right piece. That means that the address of the number 3/4 in the Cantor set begins with R. Now, we're really not concerned with the address of 3/4 itself. We did that operation because we wanted to know what's the next letter in the address of the number 1/4. And what we've learned is that it must be an R, right? Since the first letter in the address of 3/4 is an R, that means that the second letter in the address of 1/4 is R. Now, again, I should also say, how did we know that 3/4 was in the right piece? Well, that's because we know the right piece of the full Cantor set starts at 2/3 and goes to 1, and 3/4 is greater than 2/3. Okay, so we've now taken 2 steps of the process of generating the address of the number 1/4. We first saw that there was an L, and then we saw that there was an R, so thus far we've generated LR. One continues on in this same fashion, generating a string of L's and R's. You can continue this process as long as you like with any given number, or maybe even if you're clever, you can figure out how it's going to go forever. Now, this whole process that I'm talking about here can be mechanized. That is to say, if you give me a number in the Cantor set, I can just follow blindly some instructions over here, mindlessly. We could ask somebody to follow these instructions, not even telling them what it is they were doing for us, not telling them that they were generating an address for a number in the Cantor set. So what you should do is to look for a handout that looks like this. You're going to take this handout to recitation. You want to be referring to it right now as I continue this lecture. The handout is called Cantor Address Generator, and it presents a flowchart for generating the address of a specified number. You're going to use this flowchart in the recitation to find the addresses of some selected numbers. Now, when I say it's a flowchart, I'm saying that we start at the very top and we follow the instructions that are there. In fact, let me move along to my next slide. It's still showing us the same flowchart, and it's now telling you exactly how you're supposed to use it. You start always at the top. So given your number, you start at the top, and you follow the arrows as needed, and you also follow the instructions. Sometimes you need to answer a question. You'll answer that question with either a no or a yes. It's a factual question. You just have to decide, is the answer no or yes? And depending on your answer, you'll then follow the correct pathway. And you'll notice that very often what it tells you to do is to loop back where you were earlier. In fact, if you're working with a number in the Cantor set, you're going to loop through this box forever, through this flowchart forever. We can actually apply this process to a number that's not in the Cantor set and take any number between 0 and 1 and follow these instructions. And if the number's not in the Cantor set, what eventually will happen is when you get to that box almost at the bottom that says, is your number greater than 1, you'll answer yes, and what you'll have discovered at that point is your number wasn't really in the Cantor set. It was maybe close to the Cantor set, but not in the Cantor set, and so you should stop, and you're done. If it is in the Cantor set, this process will go on forever. It will yield an infinitely long string of L's and R's. Now, you may be able to shortcut this process. Right, I've said it goes on forever, so it would be nice if you could finally end it. And you can do that if at some point you find that you've returned to the very same box you were at earlier and that you're dealing with the same number as earlier. Because what that means is that your string is going to repeat the same block of symbols forever. If you try this with the number 1/4, let's in fact try it. You start at the top with the number 1/4, you multiply by 3, that gives you 3/4. 3/4 is not greater than or equal to 2, so we said no, and we put an L at the end of the sequence. Well, where L is at the beginning, right? It seems sort of funny to say put it at the end. You should imagine you start with an empty string or an empty sequence. So to put something at the end means just to write it. It's the very first thing you're going to write. So we put down an L. Now we're going down to the box even further down. Is your number greater than 1? No, it's not. 3/4 is not greater than 1. So now we're following an arrow that tells us to go back up to the top, multiply our number by 3. Well, that is the number 9/4. Is that number greater than or equal to 2? The answer is yes, it's greater than or equal to 2. So now we put down an R. And then the next instruction says subtract 2 from your number. Are you following me? I have 9/4. I've just written down an R at the end of my sequence. And now I'm going to subtract 2. This gives me 1/4. And now I loop around. I come back to the box at the top. It says multiply your number by 3. And now we have the number 3/4. Well, that's the same number we had before, right? When we first multiplied our initial number by 3, we got 3/4. So we're back to the same box with the same number, 3/4. That means that the string of symbols that we have just generated, the L and the R, is going to repeat forever. The block LR will repeat forever in the address of the number 1/4, and so the address of the number 1/4 is LR, 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 and so on forever. Now, what about the other way? Can we reverse this process? In other words, if we're given an address consisting of a strings of L's and R's, can we produce a number? Well, I've already said that we can. In fact, we can. However, I'm not going to give you the general recipe for doing that, and that's partly because, well, that general recipe would actually involve summing an infinite series, and that's not a topic that we learn in Math 11:16. But let's just take one particular case where we don't have to think about the elaborate general recipe. Suppose I give you the address L, R, 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 etc. That is to say, a single L and then R's forever. Now, what number is that? Well, let's go back and look at our earlier picture. So I'm going to go back through my slides somewhat. I'm going to go back to this slide, associating an address to a number in the Cantor set. But remember, we're going the other way, right? We're given an address and we want to get a number. Well, the address was L followed by R's forever. So since it was an L, that means that our number is somewhere in the left piece. So it's somewhere in that interval 0 to 1/3. However, after the initial L, it's R's forever. So what does that mean? What that means is it's the rightmost piece, I should say the rightmost point of the piece on the left, right? It's always going to be to the right. So that must mean it's the rightmost possible point. So it's at the right end of the left piece, and we know what number that is. That's the number 1/3. Okay, so here's what we've learned. If you're given the address L followed by R's forever, then in fact that gives you the number 1/3. You're going to do some more of these in recitation. I'm not going to give you any general recipe. As I've said, it's too complicated. And in fact, it's probably a better learning experience to actually try simple examples. So in the recitation, you're going to be given several other examples like this. You're going to be given addresses and asked to work out what are those numbers in the Cantor set.